Good afternoon. This is a video tutorial for manufacturability analysis tool. So I've downloaded all the files in a folder. Make sure to download your STL models in the same folder. So first we go into MATLAB, and when you use it for the first time you have to set the path to the directory where you have downloaded all the files. So we go to home, set path. In that I have already added the path to this folder, but you can go in add with subfolders and select the location where you have downloaded all the files and then select the folder. So this adds all this folder and all its files to the MATLAB root directory. Now once you have done this, to run the tool, just you have to type a run command and name of the file which we have to run, which is in this case main. So I write run main. So first it will ask for you to enter the file name. So you have to enter the file name with .stl extension. Whatever is your name of the model that you're trying to print, you just write that name and follow it by .stl extension. So here I am using a sample teapot model for demonstration. Next it asks for the units in which you have made the model in CAD. So enter 1 for millimeter, 2 for centimeter and 3 for inches. So just for demonstration I'll press 1 for now. Next it asks to enter the material in which you want to make the part. Since we are using ABS for the project, will always enter 2 here in this field. Next it will ask you to set an orientation for your STL model. So whatever is your original orientation, if you want to rotate your model in XYZ, so you have to enter the angle by which you desire to rotate your part. So it asks for first it asks for X orientation. You have to enter the value in degrees. Suppose I say 45, I want to rotate my file in X by 45 degrees. Then it asks for the desired orientation in Y. Similarly it asks the same value in Z. I'm just entering 0 for now. The program is now running and calculating different manufacturability metrics, and it takes 2 minutes to run. After that you'll see that in your command window you'll see some results. So here I'm highlighting the results that it has given. In addition to this, it also generates 3 figures. You can see that the total model material required is 74272 mm cube. You will get the part weight. Similarly, it will tell you the total support material required, the time required to make this part, and the cost required to make this part. So in the project, your aim should be to minimize the total material required, total support material required, and take as much less time to print the model and be cost effective. So basically this can give you useful feedback, and you can run iterations on this software to improve your design. So figure 1 is the original STL model that you prepared. You can rotate this by using this rotate button. So this is the original STL model that you made in CAD. Figure 2 is the rotated STL model in its new orientation. You can see that I rotated it by 45 degrees. Figure 3 is the figure which gives you feedback on manufacturability. It helps you to visualize which which of the overhang requires support material. So in this you can see that in the teapot, in this orientation, the top as well as the handle would require some orientation. We have set the critical angle as the angle of the machine that we are using, which is Fortus. So according to that, it will give you the amount of support material required. The features highlighted in white are features which are below machine resolution or are very thin, that may or may not print. If they print, they would not be of correct shape, or they might be distorted. So you may notice that there may be some one or two here and there, one or two small cubes that may be highlighted. So don't worry about them, because they might be stray voxels. But if a feature is lighting up in white too much, like this top of the teapot or the end of the opening in the kettle here, so then you need to check with like the thickness that you have chosen for that part. So this can, like, if you have a very small feature in your part, it may happen that it may not print correctly. If your feature has small negative features such as holes, drafts, etc., and if they are also less than the resolution of the machine, they may also show up in white. It may be possible that you have made a feature which might not entirely show up in this graph. If it doesn't show up, then you can be sure that it won't print on the machine. So try to look for thin features and missing features in this graph. So this is the end of this video tutorial. Thank you for listening to this.